Okay. Hi everyone. I just give you back the prerequisite review. So if remember, this is just for me to know you more and help you prepare for this course. So it's not count toward your homework or any grades here. Okay. So if you get A, it means you're ready for this course. So if you get B or C, it means you have some mistakes here. I hope you can redo those problems and come to see me. Did you turn in your prerequisite review?
Yeah.
Oh, what's your name?
Matteo Raymond.
Matteo. Okay.
Yeah. Thank you.
Yes. So if you get B or C, please redo the problems you got wrong and then come to see me. Is that okay, everybody? So I want to regrade your problems. I want to make sure everybody not fall behind and you can understand. Because if you don't know how to do certain type of problems, I can give you more resources. So do you get your, what's your name? Sylvie. Okay, here you go. Alright. So yes, redo the problems you got wrong and then come to see me. So my office hours is let me see. So here, our course website. My office hours is before our class and after our class. And Tuesday from 11 to 12. Or after 2 p.m. I will also be in my office. So if you get B or C, please redo the problems and then come to see me. Is that okay, everybody? And I want to mention that this is our blackboard, right, everybody? You go to the left. Do you see this is Mobius lessons? Okay, click that. Then you click the Mobius lessons. It will direct you to more resources. So prerequisites, many of you forget like how to factor a polynomial. So click this lesson, factoring polynomial. And then it will talk about how to factor monomial and find the greatest common factor of a polynomial. Factoring a trinomial with the leading coefficient is 1, and factor by grouping. So, and here at the bottom, there are more exercise. So you can try to work on it and put your answer here, and then you can click how did I do. So it show you the solution. Okay, everybody? So this is like how to factor. And besides that, perfect squares. See this formula, perfect squares. And difference of squares. Okay, so difference of squares right here. Yeah, remember on some of the problems we need difference of squares? Yes. So they have exercise here. So you can plug in your exercise. How did I do to check your answers? If you need more exercise about factoring. Is that okay, everybody? Yes. All right. So this is the Mobius. And yeah, besides the factoring, if you want like more exercise, for example, you want more exercise like your homework, you want more exercise besides your homework, you can always go to the sessions and it's like a textbook, but it has a lot of exercise. So, and these exercise, you can plug in a number and you put how did I do to check your answers. Is that okay, everybody? All right, your homework. So, do you all know that this Friday we have our first quiz? The first quiz, it covers 1.1 to 1.3. Okay, so I suggest the quiz is not in class. The quiz is in Blackboard. Okay, you have a whole day to start the quiz. So it will be available after the midnight. You have 24 hours to start the quiz. Once you start it, you have to submit in 30 minutes. Okay, it has 2 questions. And I strongly recommend you to finish your homework before you take the quiz. So review your lecture notes and maybe some of you realize that your homework has more types of problems. You might see some problems that we were not able to cover in class, show in your homework. So I would say, because college algebra and trig is a lot, I cannot cover all types of problems in class. So your homework, you will see more different kinds of problems. But I can promise you the quiz and the exams are the problems that we cover in class. Okay? So your homework has more problems, more different type of problems. You can open your mind. And because the homework, you can do it again and again, and you can know whether you're doing right or wrong. So let me emphasize, I'm not sure if you realize. So if you like type something, okay, maybe let me go to the next problems. And if you just click something and there is a button, how did I do? So if you get that correct, that's correct. If you get it not correct, then you can choose the other one. So you can know whether you're doing right when you do the homework. Okay? Do you all know the how did I do button? You can check your work. So like this problem, see, you can type some numbers and then you click how did I do? Then you can see whether you get it wrong or wrong, right? And after you submit, let's say you go next, and then you submit assignments, okay? And you click submit the assignments. Do you see view details? You click the view details, it can tell you this is your response, and this is the correct answer. And there are some explanation why this is the correct answer. Okay, everybody? So that is your homework. And if you have questions, please feel free to come to ask me. Okay. And besides that, so I also post this is a link to our sample homework solution. Okay. So I would say the first attempt, try not to look at the solution. And the second attempt, you can, second attempt, then you can look at the solution and figure out what's wrong. Because sometimes it might be the way when you enter the answer you got wrong. For example, 1.2, when they ask you to find the domain and range, and you type infinity for infinity, right? And you type the parentheses, not brackets, for infinity. So you can look at the way how we type the answers to figure out whether you type the answer correctly. And also, let's see, this one. Okay. Remember 1.2? So you get this piecewise function and you need to draw it, right, everybody? So let me just make an example how to draw it here. So it has two p's. This piece x is less than 1, right, everybody? So you find where the 1 is and you plug in here. 2 times 1 minus 1 is what? 1, right, everybody? So we have a point here, right? And then, okay, less than 1. Let's take 0. If you plug in 0, what do you get? You get negative 1. So we have 2.11 and 0, negative 1. We can draw the line. So you click this, and then you plug those 2 points. So 1, 1, put a point here. 0, negative 1, put a point here. See, after you put those 2 points, it gives you a line. But here, x less than 1. This is only the left part. You don't want the right part. So do you see this little scissor? This means you cut out the left part. This means you cut out the right part. And we don't want the right part, so you click this. Okay? So you click this. And click the dot again. Do you see now you only have the left part? And oh, look at this. Less than 1. Can it be 1? No. Do you include the endpoint? No. Look at this symbol. It changed the solid circle to open circle. So you click this button and dot. So see, it changed to open circle. So this is one part. Now can you do the rest? Draw the line first, and then you decide to cut the left part or cut the right part, or look at the endpoint. Do you include the endpoint to decide whether you change to open circle? Okay, attendance. All right, thank you. Okay, so that is the homework. If you have any questions, always feel free to ask me. Yes. Let's see. Do we start recording? Oh, okay. Thanks. Yes, we did. Okay, good. Okay, good. Thank you. So yes, that's the homework. If you have like more questions, feel free to ask me. And you can redo the homework again and again until you get perfect scores. Okay? Yes. All right. So let's see. Okay, so today we talk about session 1.4. Okay. Composition of functions. All right. So 1.4. We finished 1.3 last time, right? Okay, good. All right. So suppose you have two functions f and g. You can add them, subtract them, multiply them, and divide them into new functions. Okay, so let's look at, something wrong here. Oh, wait, I should not show that. Okay, so here, arithmetic of functions. The sum f plus g is f of x plus g of x. Makes sense, right? We just add those two functions. And the difference is f minus g, right, everybody? And products, just multiply them together. And quotients, divide them together. But when you divide, well, make sure your denominator cannot be 0. Right, everybody? Okay, so let's look at example 1. We have f and g, and let's figure out all of those. So f plus g, okay, f plus g of x is f of x plus g of x. F of x is 1 over x minus 2, plus g of x is square root of x. So far, so good, everybody? Okay, and that's it for f plus g, right? We're just write down the f and then add the g, right? Okay, how about f minus g? Well, just write it down. F is 1 over x minus 2, and minus g is square root of x. Is that okay, everybody? And then f times g is f of x times square root of x. Usually we can then move it to the numerator. So it becomes square root of x divided by x minus 2. Right, everybody? Okay, and then f over g. So f over g of x is then f of x over g of x. Right, everybody? But when you do something like that, and let's try to simplify. You know, a over b over c over d is a over b times the reciprocal. So it becomes d over c. Right, everybody? So in this case, a is like 1. B is like x minus 2, right? And the c is like square root of x. And the d is like 1. Do you agree? So when you rewrite it, your a is 1, so 1 is on the numerator. And then your x minus 2 is downstairs. Right, everybody? C is upstairs or downstairs? Downstairs. So you square root of x. Put it downstairs. So multiply by square root of x downstairs. And don't forget your baby. What's your baby? Parentheses. Yes. Because you mean the whole thing multiplied by square root of x. You don't want just x minus 2 square root of x. You want x also multiplied by x. Okay, everybody? Mm-hmm. All right. Let's continue. Oh, sorry.
Oh, sorry. I didn't mean to sound so aggressive.
Maybe I can shrink a little bit and we can still see it. Okay. Yeah. Because this is the door. They only have this space. If I move so quickly, please feel free to slow me down. Yes. Okay. Right. Okay, example 2. Consider the functions whose graphs are given below. F plus g of 2 is, so this is f of 2 plus g of 2, right, everybody? How about you guys take turns to answer my questions? Hi, Sierra. Sierra. Yes, yes, help me to learn. Okay, Sierra. So what is f of 2? 2 plus parentheses negative 1 equals 1. Yes. So f of 2 is 2. And g of 2 is, see? X is 2. F of 2 is 2. G of 2 is negative 1. Right, everybody? Mm-hmm. Good. Negative 1 right here.
Oh.
Yeah. This is 2. Yeah. The F is the blue line. It's 2. The G is the orange line. Do you have color? No? Okay.
Nah.
Okay.
But I can see the F and G. That's all that matters.
Okay, good. Yes, so this is minus 1. And 2 minus 1 is 1. Okay, good. Part B. We have G of negative 2 minus F of negative 2. Right, everybody? Mm-hmm. So, Natalie? What's your name? Catherine. Oh, yes, Catherine. Okay, so what is G of negative 2? G of negative 2.
1.
Yes, here, 1. And minus, what is F of negative 2? Yes, yes. And 1 minus 3 is negative 2. Yes, good. Okay, and next, F times G of negative 3. So F of negative 3 times G of negative 3. Right? Denise? What is F of negative 3? Oh, do you see it? It actually stopped here. We have with no value at negative 3. Right? So we can say undefined. Even though the G is defined, but as long as your F is undefined, you have nothing to multiply by.
If either of them is undefined, then the whole thing is undefined.
Yes,
Okay.
exactly. So undefined. Is that okay, everybody? Mm-hmm. All right. And then how about 4? Oh, then this is f of 4 times g of 4. Okay. Next, what's your name? Evan, yes. What is f of 4?
0.
Oh, yes, 0. And g of 4?
-4.
Yeah, thank you. Oh, so the answer is 0. Right? Good. Okay, next one, division. F of 0 over g of 0. Okay, next. Okay, I'm learning your names. What's your name? Natalie. What is f of 0? So, 0 here. What's f of 0? 3. And what is g of 0? 2. Yeah? Okay. So 3 over 2. Right? So f of 0 here, 3, and g of 0, 2. Okay, everybody? All right. Okay, so that is addition, subtraction, multiplication, and division. Next, when you plug a function into another, it's called composition. Okay, you plug in another function. Okay, so this is the formal definition. F and G are functions. X is in the domain of G, and G of X is in the domain of F. Then we can form the composite function F composite with G. So the composite is really like a circle, right? But you have seen the circle before. Temperature, right? Temperature, and this is the degree of Fahrenheit. In Europe and China, we use degree Celsius, right? You use Celsius. Okay, so yeah, Italy use Celsius. Okay. Is Italy hotter or cooler than here?
Oh, it's pretty similar because in summer it's humid and winter is not that cold actually.
Snow? Will you see snow?
It depends on your region.
Oh.
That's my first time being to see snow.
Oh.
What? I felt like this. Oh my gosh.
Okay, good. Because snow sometimes, if it's very big snow, we gotta stay at home. I know that.
And they told me that there are anyway a line classes.
Oh yeah. So sometimes we switch
Maybe
to
after
online.
COVID.
Yeah. Yeah, because right now we all use the backward line anyway. So if you're at home, yeah, you can still learn. Okay, and also you see degree like the angle. Let's say this is 60 degrees. You also put a circle. But this circle, you don't put it on top. You put it at the middle. That is composite. So F composite G means F of G of X. Okay? So you have X, and then you apply the function G, you get G of X. And G of X, you apply the function F, you get F of G of X. It's like a two-step process. Okay? And so the composite function is now F composite with G of X. All right. So that's why here. So here is the domain of. So this is G, right? So this is the domain of G, right? And then here is the range of G. So the range of G, but because you want to apply the F, then you also want to make sure the range of G is in the domain of F. Right? You make sure the range of G is in the domain of F, so then you can apply the F, and then this is the range of F. Okay, everybody? Remember, domain is the input X, range is the output Y. Okay, so let's see. Okay, the following table gives some information about F and G. Completes the following. Okay, so F composite with G is F of G of X. And then here you plug in X is 0. So this is F of G of 0. Right, everybody? Okay, next student. What's your name? Huh? Leslie, yes. Let's look at from the inside to the outside. When we evaluate from the inside to the outside, what is G of 0? What's G of 0? 8. Yes, G of 0 is 8. Good. So the inside is 8. And then we have F of 8. What's F of 8? 21. Yeah, very good. So we got 21. Yes, that's it. Exactly. Right. So we look at the table and figure out the x back to 8 for g, and then the f maps the 8 to 21. Okay. And then 1, so you plug in 1, you get f of g of 1. Okay. Next, what's your name? Maddie. Maddie. And what's g of 1? 5. 5. Yes. So that's 1 map to 5. And what is f of 5? 30. Thank you. Yes. Very good. So keep going. What's your name? Hella. Yes. What is g of 2? 9. So we get f of 9. And what is f of 9? 18. Yes, very good. Right, everybody? Okay, Lucas. F of 6 is
27.
thank you. Yes. Right. And what's your name? Taylor. What? Jaden. Jaden. Oh, okay. So f of g of 4 is f of 7 is 24. Yes. So this is given the table values. How do we compute the composite? Good. Keep going. Oh, everybody finished? Mm-hmm. All right. Now, if we are given formulas, what is F composite with G and what is G composite with F? All right. So F composite with G is F of G of X. And you always evaluate from the inside to the outside. So what is G of X? 2x minus 3. Right, everybody? 2x minus 3 is G of X. And then f of 2x minus 3 is, you look at the formula. Every time you see x, replace x by 2x minus 3. Right, everybody? Oh, okay. Mm-hmm. So we have 5. And then times 2x minus 3 squared. Am I right? What do I mean? Parentheses. Yeah, my baby. So when you do this composition function, be careful with parentheses. All right, everybody? So yeah, especially because you don't have x, you have something more than x, you want to make sure it's like everything raised to the power of 2. All right, so this is part A. Yeah, so questions? So then the next one would be like the F and G. Exactly. Yes, very good. The next one, the G is outside, the F is inside. So what is F of X? 5x squared. Yeah, 5x squared. And now you look at the G. And every time you see X, replace X by 5x squared. Right, everybody? So we have 2 times x, replace x by 5x squared. And then minus 3. Do I need a parentheses here? We can put it, but it's not necessary in this case. Right, everybody? So 2 times 5 is 10. X squared minus 3. So far, so good? Mm-hmm. Okay, C. Compute the values of F composite G of 1 and G composite F of 1. Oh, notice that. Are they the same? Are they the same? This one and this one, the two functions, are they the same? No. So the composite function, the order really matters. F composite of G and G composite of F, they're not the same. It's not like multiplication. They're not the same. All right. So that's why when you write down something on your paper or quiz or exam, make sure I can tell the difference of multiplication and composite. Okay, this is multiplication. This is a composite. So enjoy it. Okay. So yeah, make sure you can tell this is multiplication or composite. If you mean composite, draw an open circle. Okay? Don't fill in. If you fill in, I would think this is a dot. Is that okay, everybody? So make an open circle. Then this is composite. Okay. All right. So F composite G of 1 is, you plug in 1 into here, right, everybody? So 5 times 2 times 1 minus 3 squared. Oh, what's 2 times 1 minus 3? Negative 1 squared is 1. Ooh, so 5. And here, where you put the dot, 5 times 1 is 5. And don't put your dot here. You put your dot here, this is 5.1. Okay, everybody? Yes. All right. Next one, G composite with F of 1. So we use this formula, right? So 10 times 1 squared minus 3 is 7. What? Right? 10, is it here? You plug in x is 1. So yeah, 1 squared is 1 times 10 is 10. 10 minus 3 is 7. Oh, yes. See, because we don't have a parentheses here. If we have a parentheses, it would be 10 times 1 and then 10 squared. Yes. So your baby parentheses is very important. Very important. It makes a big difference. Yes. Okay. All right. Yes. Very good. Very good. I really hope that our class is like a family. All of you are brothers and sisters, and we are learning math. And if you have questions, don't be afraid of asking. Okay? So I'm here to help you. And I guess you're gonna take more math classes besides this one, right? Oh wait, not? But statistics, right? Are you taking statistics in the future? Yeah. Okay. All right. Let's keep going. Evaluate f of g of 2. So always evaluate from the inside to the outside, right? So from the inside, what is g of 2? Nathan. G of 2. Yes. See, everybody? G of 2 is 0. Okay, so that's 0. Okay, that's 0. And now what is f of 0? Minus what? Negative 3. Right? Yes. Yeah, negative 3. Okay, negative 3. Good. Yes, very good. Okay. How about, let's see. Yes, very good. Okay, how about if I ask you f of g of 1? What's that? G of 1 is, oh, this is not a good number because it's not an integer. Okay, let's say it's 3, okay? Let's pretend it's 3. Yeah, then g f of 3 will be, what's f of 3? It will be 6. Yes, it's actually 6. Okay, everybody? Oh, what if I change the number? I'm just making up the problems. Let's see which one I get. How about 2? Let's do that. Let's do 2. Okay, what's f of 2? 5. And g of 5? Yeah, let's say it's 3. Okay. Is everybody okay? Alright, you just look at the graph of f and g respectively and evaluate from the inside to the outside. Okay. Alright. Okay, the domain of a composite function. The domain is the set of those input x in the domain of g for which g of x is in the domain of f. It looks complicated, but it's okay. I would say just figure out what is the composite function, and then remember our rule for domain. You look at square roots and you look at fractions. Okay? So yeah. Okay, let's figure out the composite function. So f composites with g is f of g of x. And you evaluate from the inside to the outside. Right, everybody? So let's see. What is g of x? Yes. Okay. And f of this means, look at the formula of x. Whenever you see x, you erase x and replace by this. So 5 on top. And then, the x. We replace the x by 4 over 3x minus 2 and minus 1. Yes, so this is the formula. 5 over x minus 1, right? And then you erase the x and replace by this expression. Yeah. Right, everybody? Okay. Ooh, this is so complicated. Let's simplify it. Okay, let's simplify it. Do you see two fractions, we combine them, we look at the common denominator, right? So common denominator is, 3x minus 2, right, everybody? So you have 4 here and minus, how do you get a common denominator? Yeah, multiply the top and bottom by the common denominator, right, everybody? So it's then minus 1 times that. So it's like minus parentheses 3x minus 2. Here, make sure you include the parentheses, because when you break the parentheses, this minus will change the sign. So the negative 2 will become positive 2. Exactly. Alright, so let's continue. Oh, it's multiplied by 1. Oh, yeah, you can put the 1 here.
So the 1 is on the top.
Yeah, on the top here. Yeah, just multiply by 1. Yeah. Anything multiplied by 1. But if you want it to be there, yeah, we can put it there.
Well, I just didn't know if it was like separate from the fraction, like the first one.
Oh. Yeah, the 4. So this number is always on the top.
Okay.
Yeah, always on the top. Right. All right. So next we have 5. Simplify it. 3x minus 2. And you get 4. Now let's get rid of the parentheses. So we get minus 3x, right? And then plus 2. that okay, everybody? Alright, so keep going. 5 over. Let's combine the like terms. What is 4 plus 2? 6. Oh, so we have 6 minus 3x over 3x minus 2. And, okay, remember we have a over b over c over d is a over b times d over c. Right? When you divide it by a number, it's the same as multiply by its reciprocal. Right? So I would say divided by a number is the same as multiply by its reciprocal. So the reciprocal is what? The top you put, very good. And the bottom, yes, yes. So you can kind of put the parentheses here. Your 5 will be considered as in the numerator. Yes. Okay, so this is how we simplify it. Okay, very good. And here, I also want to emphasize the line. The length of the line really matters. Okay, do you see this is longer than this? Do you see this line is longer than this? Yeah. If I put, okay, this is outside of this problem. If I put this shorter and 6 minus 3x, this line is longer. If I make this bottom line is longer, it actually means this is A, this is B, and this is C. Okay? Then this will mean that A over B, and then your C will be in the denominator. Okay? So this will be 5 over 6 minus 3x, and then the 3x minus 2 is in the denominator. So when you draw the line, make sure which one is longer. Is that okay, everybody? All right. Okay, so this is the composition, right? And we say the domain of this is the set of those inputs x in the domain of G, for which G of x is in the domain of f. Okay. So let's write it down here. Do you still have space here? Huh? Okay. So what is domain of G? So you look at the G. Okay. Let me remind you. Domain, you look at two things. Do you see square roots? If you see square root, you need the things inside the square root to be greater or equal to 0. And the second thing is, do you see fractions? If you see fraction, you need the denominator not equal to 0. Right, everybody? So, this is G. Do you see square roots? No. Do you see fractions? Yes. So your denominator cannot be 0. So 3x minus 2 cannot be 0. Is that okay, everybody? So you get, okay, add 2 on both sides. You get 3x not equal to 2. And both sides divided by 3. We get x not equal to 2/3. Is that okay, everybody? And let's see. How about the domain of f? The domain of f, you look at f. Do you see square roots? No. Do you see fractions? Yes. You need the denominator not equal to 0. Okay, everybody? So you get the denominator is x minus 1 not equal to 0. So x not equal to what? 1. That's the domain of f. Okay, everybody? Huh? The top, do we care about the numerator? No. So the numerator, yeah, doesn't matter. So we only care about the denominator. It cannot be 0. Yes. Okay, good. Okay, now the domain of F composite G. Okay, this will be X is in the domain of G. See? The domain of the composite function is the X in the domain of G, and for which G of X is in the domain of F. Okay, so this one and G of X is in the domain of F. Is that okay, everybody? So X in the domain of G. This means the domain of G is right here. Yeah? So this sentence means X cannot be 2/3. Okay? So this means X cannot be 2/3. But G of X in the domain of F. Okay. Look at G of X. It's right here. Yeah? This is G of X. In the domain of F, it means G of X cannot equal to 1. Okay, everybody? So G of X is 4 over 3x minus 2. And this cannot be 1. Is that clear, everybody? Alright, so you solve for x. Both sides multiply by 3x minus 2. You get 4 not equal to 1 times 3x minus 2. Is that okay, everybody? We multiply that on both sides. And then 1 times anything is that thing, right? So this is 3x minus 2. And what do? You add 2 on both sides. Yes, we add 2 on both sides. We get 3x not equal to 6. What do we do next? Divide by 3. So x not equal to 2. See? You get x not equal to 2 and x not equal to 2/3. If you want to use the, I ran out of space here. Can I do it here? So x not equal to 2/3. So you put an open circle to indicate you want to remove that point. And x cannot be 2. Therefore, your domain of F composite G will be minus infinity to 2/3 union 2/3 to 2 union 2 to infinity. Is that okay, everybody? All right. And if you just look at the composite function, this is a composite function, right? If you just look at this function and you want to find the domain, well, we don't care about the numerator, right? We care about the denominator, right? So you set your denominator 6 minus 3x is not equal to 0. Then you add 3x on both sides. You get 3x not equal to 6. And you divide by 3. So you get x not equal to 2. So by looking at the formula, you only get x not equal to 2. So you actually miss this information. You need both. Okay, everybody? So, yeah, 2 conditions. X is in the domain of G because G is the inner function, right? You want to have G add on X. Your X is better in the domain of G, right? And then your G of X should be in the domain of F, right? So G of X, write down what's G of X and figure out what is the domain of F. So replace X by G of X, set it not equals to 1, then you can solve this. This is the domain part is more complicated for composite function. Okay. So far, so good, everybody. All right, good. Next one, transformation of functions. Okay, good. We love to draw graphs. So now let's draw graphs. By the way, do you all get these t-shirts?
Yes.
No? If no, you can go to Office of Student Engagement. You know the dining hall where you have lunch and the Office of Student Engagement, and you can ask them for the t-shirts. Yes. Remember what President said? We make it happen. Have a plan. Ask for help. Were you there? Okay. Let's practice again. We make have a plan. Yes. Okay. Good. All right. Um. Next. Okay. So transformations of functions. So let's look at this example. All right. Let's review. Everybody, move your hands. Line. X square. X square. Problem. X cube. Square roots. Cube roots. Yeah. Absolute value. Right. Reciprocal. This is the Indian yoga. Have you been to yoga class? Oh, you've been to, oh, they just did this, right? Oh, okay. So just show your hands a bit. Okay. Interesting. All right. So, absolute value of X. What does it look like? This, right? Yes. Oh, when I ask my daughter to take pictures, sometimes asking her to do this. Okay. Yes, absolute value of X. Okay, absolute value of 2 is what? 2, absolute value of 1, 0, negative 1, negative 2. Perfect. So let's plot those points. 0, 1, 2, 1, 2. Yes. This is absolute value of X. Right, everybody? Okay. If we add 2, what happens? Oh, do you see when the Y value add 2? It's like all these numbers, we add 2 to it. Right, everybody? So we get 2 plus 2 is 4. 1 plus 2, 0 plus 2. Next, 3, 4. Oh, it's all these numbers plus 2. Yeah, this is absolute value of X, and we add 2 to it. So we look at these numbers, we add 2. Yeah. Right. Okay, and let's plot the points. 2, 4, 1, 3, and 0, 2. Bless you. Negative 1, 3, negative 2, 4. Okay, and connect them together. So this is the absolute value of X plus 2. All right. Actually, you can see the picture. What do you do to it? Yeah, raise up for 2 units. Right, everybody? Shift up 2 units. Okay, how about this? Subtract 2. Right, look at this number. 2 minus 2 is 0. 1 minus 2. 0 minus 2. And then? Yes. So 2, 0 here. 1, negative 1. 0, negative 2. Negative 1, negative 1. Negative 2, 0. And connect them. Yes. Okay. Can you draw a straight line? Yeah, use your student ID. No. No, your cell phone. Oh, in the exam you cannot bring your cell phone. You can bring your student ID. Or maybe another pen, pencil.
We can just pretend it's straight.
Okay, sounds good. Okay, so summary. To obtain the graph of absolute value of x plus 2 from the graph of absolute value of x, we say we what? Shift up 2 units, right? So we shift up 2 units. And to obtain the absolute value of x minus 2 from absolute value of x, yeah, exactly, shift down 2 units. So far, so good, everybody? Mm-hmm. All right, let's keep going. So this is vertical shift. Okay, so if you have your entire function add or subtract number, you're gonna shift it vertically, up or down. Okay, that's one transformation. Keep going. Okay, so here, absolute value of x, we still know that 2, 1, 0, 1, 2, right, everybody? It's still the same thing. Maybe we can just copy it here. Okay, yes, this is absolute value of x. Okay, now something new is, look at this. 2 times absolute value of x. These numbers are absolute value of x, right? Exactly, multiplied by 2. So 2 times 2 is 2 times 1? 2. Yes. Next one, 0. Next one, 2. And then 4. Yes. Okay, let's plot the point. 2, 4. Here. 1, 2. 0, 0. Negative 1, 2. Negative 2, 4. Okay, connect them together. Okay, yes. Oh, this is the new graph.
Oh my gosh.
So far, so good. Okay, can you see from this picture to this picture? It's like you can stretch it. Yes, you stretch it. So it's more skinny, right?
Yeah.
Yes. You play with Play-Doh slimes? Oh, my daughter really likes slime. That's why sometimes we make things messy. Okay. Yes, stretch. Yeah. Yesterday she showed me the one that her friend gave to her. It was like blue and a lot of like shiny glitters. Yeah, she's so happy with it. And then after she played the slide, her hand is full of glitters. and fall off the ground, the sofa, the chairs. Oh, oh yeah. Okay, let's continue. So this one is you multiply by 1 half. Okay, everybody? So it's all these numbers multiplied by 1 half. So 2 times 1 half is 1. And then next. And then? Mm-hmm. Yes. Okay, so 2, 1 here. 1, 1 half, 0, 0, negative 1, 1 half, negative 2, 1. Okay. So this is like stretch. This is like compress. Right, everybody? You have squishy mallow. I have a set of squishmallow. I like a couple of years ago I bought the set of squishmallows, $16 from Costco. It has 8 of them. And then now I search Amazon, it's like $80. The price raised a lot.
You need to get the big one, so it's like a giant filler.
Yeah, oh I also have a big one. This is like $20.
Target.
Target. Oh yes. And like the I think I bought one is like unicorn cats for my daughter. Yes. Uh, my son saw it and he wants one. I know. I thought for boys they like cars and dinosaurs. So He also likes squishmallows. Okay. Alright, so to obtain 2 times absolute value of x, we stretch by a factor of 2. Okay. So, and please put down we stretch vertically by a factor of 2. Alright, because we have vertical stretch and we also have horizontal stretch. So the say is stretch vertically. Okay, next one here. There are 2 ways you can say. You can either say stretch vertically by a factor of 1/2, or you can say compress vertically by a factor of 2. You see the difference? Compress by a factor of 2 and stretch by a factor of 1/2. Okay, so in 2 ways you can do. You can say compress vertically by a factor of 2 or stretch vertically by a factor of 1/2. But don't say compress vertically by a factor of 1/2. Okay, everybody?
Wait, what did you say?
Don't say compress vertically by a factor of 1/2. Because that would be the same as stretch vertically by a factor of 2. Yeah. All right. Very good. Okay, keep going. Yeah, let me just write it down. Okay, use a red color. Don't say compress vertically by a factor of 1/2. That would be wrong. Okay, either compress by a factor of an integer or stretch vertically by a fraction. Okay. All right, keep going. Okay, so absolute value of x we know is 21012, right? This is still the same. So okay, connect them. This is a let me draw it better. Okay. It ugly lines. Okay. So ugly. I can't stand it. Let's do it again. Okay. Alright. Okay, so right now, here, instead of, see, do you see this plus 2 is inside the absolute value? Yes. Okay. So this means when x plus 2 is 2, find the x. Okay, so it's the x plus 2? Yes. Okay, so very good. So yeah, you set this equal to 2. So you're doing, absolute value of x plus 2 equals to 2. And you want to solve for x. So actually, x plus 2, when you get rid of the absolute value, you can get positive or negative 2. Is that okay, everybody? Because positive 2 will give you 2. The negative 2 will also give you 2. So when you break the absolute value, you actually get plus or minus 2. Is that okay, everybody? Yeah. And you solve for x. So you move the 2 to the other side. It's like you subtract 2 on both sides. Yes, 0 is one of the number. So you get, yeah, you get plus or minus 2 minus 2. So if you pick the plus 2, you get 0. If you pick the minus 2, you get negative 2 minus 2 is negative 4. That's why 0 gives you 2 and negative 4 will also give you 2. Yeah. Yes. You have
Do we
two.
have to do both of them, or can we just do?
Oh, then you're missing this one.
So you start there and then.
Oh, we start with the endpoint. So this is the y. You set this expression equals to 2, and you want to solve for x. But with absolute value, when you break it, you actually get 2 roots. Okay? It's like when you take square root, right? When you take x square, you take square root, you also have plus or minus. Similar to the square root, similar to the absolute value. You get plus or minus. And you solve for x. Therefore, you get 2 x values. Both of them give you 2. Okay, everybody? And let's do different color. Okay, now how about 1? Let's do the 1. Yeah, let's see. This is 1. Very good. So x plus 2 is plus or minus 1, right? X is plus or minus 1 minus 2. So you get 1 minus 2 is -1, or minus 1 minus 2 is -3. Yeah, very good. So 1 give you that, and -3 also give you, sorry, -1 give you that, and -3 also give you that. Yes, everybody? And okay, last number is, yeah, -2. Very good. Because you get x plus 2, absolute value is 0. It means x plus 2 must be 0, so x is -2. Okay? Yes. So this is different. Okay? We actually set the expression equal to the number, and we solve for x. Let's continue next class. Have a nice day, and please work on your homework. If you have questions, come to ask me. Friday we have a quiz in blackboard, not in class. You can hold it any time of the day. Okay.
So in class, we're just gonna keep continuing with that.
Yeah, exactly. Yeah, because we do have a lot to cover in class, so I don't want to use the time for the quiz. We already used the time for exam, so. All right. Bye. Oh, okay.
I have a doctor's appointment at 7. I have to drive 3 hours home.
Oh, okay. Yes,
I'm
that's
worried about
fine.
like
So to take the quiz before you.
Just do it before I go.
Yeah.
Okay.
Bye. Okay. Okay, good. So yeah, we have the practice exams as well. So when you do those again.